you some brief introduction about our speaker today. Okay, our speaker today we have Associate Professor TS CHM Dr. Wong Yi Chin. So I hope you guys understand know what CHM means. Okay, so for your information, Dr. Wong is a expert in chemistry, and he has been with UMK for, I guess, more than 10 years. Okay. In FPKT, he's the one that we call it expert in analytical chemistry. So today he will cover topic about HPLC. I guess some of you will have opportunity to use HPLC for your final year project. Okay, without taking more time, okay, Dr. Wong, I pass it to you. Maybe you can give your proper introduction. Okay, okay, Dr. Wong, please.
Okay, right. Thank you very much, Associate Prof. Dr. Wee, for your brief introductions. I believe all the final year project students is with us now, so that I'm being invited, okay, by the committee, the final year project committee, to give introductions on high performance liquid chromatography, okay, instrumentation. So I'll give some previous SBT student which know me very well, that when I'm start on something more towards a discussion topic, I will start with fundamental first. So we'll go through some fundamentals and some breakdowns on the instrument itself, and some of the troubleshoots that you might encounter during your, how to say, your analysis, and we are trying to help solving the problems as well. Some troubleshoot, I think. Okay, so without further ado, I will go quickly on the introduction part, because I will be going to focus on the troubleshoot there. Okay, right. So what is HPLC? Fundamental things. Okay, HPLC stands for high performance liquid chromatography. Okay, whereby it's a technique on modern analytical chemistry that actually enables us to do a precise separations, and we want to quantify complex mixture. Most basically is a organic based compound, but not limited to that. Okay, it can be some of the inorganic compound, as long as it can be separated using the chromatography technique. Okay, so okay, this is some of the how you actually define your HPLC. So here we can state that there's an analytical technique, a pressure-driven system, and then it's a versatile applications. Okay, most basically it will be applied through pharmaceuticals, products, okay, environmental monitorings, and some food safety testing as well, and some biochemicals research. So these are some brief history. I will skip on this. Okay, but you can look through the slide later on, or provide to the committee so that it can be distributed to the students, so that student can have a look on that. So actually some of the background, which is from the tubes to the high pressure positions, on the innovations that being done, still part and parcel of the history on how actually this HPLC is being developed. Okay, so you might as well ask, why do you need to use HPLC? Okay, so two things that I will highlight. One is superior separation power. Okay, another one will be the ultra high sensitivity, because whatever compound that we are trying to detect in our whatever complex mixture, you need a very high sensitive instrument actually to detect it, so that in a minor or minute compound that you are going to have there, you actually can detect. This is part and parcel why do we use HPLC rather than the normal liquid chromatography. Okay. So move on to the core component of an HPLC system. Okay, you heard about HPLC. Okay, but what does the system looks like? Okay, most basically, okay, I will break down the system into four major components. Okay, you are going to have a pump, injector to inject your samples, and then you've got a column to actually separate your each and every of your compound, and then you got the detector to actually detect whatever you elute out from the chemical presence, okay, that you can quantify. You must be able to quantify through the electrical signal. Kalau you cannot quantify using electrical signal, you will become coming out as a noise, okay, from your chromatogram later on. Okay, so additional essential elements, you got tube, you got capillary, and the most important thing is the chromatography data system, or you call it as CDS. Okay, because the CDS is the one that you come out whatever chromatogram, you are going to use it, okay, as a comparison with the chromatography data system, because the data here will actually quantify not just your report, but also your peak integration, okay, vice versa, so that you can do comparison and then try to actually identify what will be the common compound that you can elute out from your sample. Okay, so first, the pump. Okay, the pump is the heart of the system. Okay, whereby it could eat the pressure. That's why you got it's being flow out. Okay, that will be pulse dampening. There were some of the how to say reaching your high pressure so that you can precisely control. Okay, whatever compound inside that can push through the column, whereby the column is quite narrow. Okay, so you need a very high pressure actually to push up all the elute from your mixture of your compound there. Okay, moving on, your sample injection, whereby it's very important so that you can inject your sample into the column by two ways. One, you inject it manually. One will be using the auto sampler. But whatever that I've noted, so if you got a single or just a few sample that you want to run the test, so basically you are going towards the manual injection. But if you are going to run for, let's say, 20, 30, okay, until hundreds, okay, of the sample, so yeah, I don't think that you are going to manage a seat in front of the machine there to actually inject the, how to say, the sample one by one. So that is the function that you are having the auto sampler. So moving on, the column, this is where you your compound being separated. So choosing a right column is very important to actually, how to say, fully separate the sample that you would like to identify from a complex compound. Okay, regardless of the column, you also need proper pressure as well as your carrier. Okay, the carrier, either we usually like using the word as a stationary and mobile phase. The stationary phase will be your column, and the mobile phase will be your whatever carrier that you are going to use. Okay, either in this case, HPLC will be in liquid. Okay. So moving on, the last part will be your detector. Okay, this is where you are translating your chemical, whatever thing that you have detected into signal. So from the signal there, we can actually collect the data and then being able to interpret. So there's various of detector that can actually being coupled together into your HPLC machine. The common one will be the UVVs. Okay, but some of them they are going to couple with IR. Okay, and some will be some of fluorescent, or you can go until mass spectroscopy as well. Okay, so you can couple a few detector that you would like to do the identification for your compound. Okay, regardless of most basically it's organic compound. Okay, because in organic compound, I don't think that people will be using this unless you are doing organometallic compound. Beside that, I think they will usually, for inorganic compound, they will use the AAS or ICP-MS, okay, to actually detect their compound, okay, for inorganic. So this one is much more towards the organic compound, okay. Like SBT student, because I'm teaching the SBT, that's why I will be quite using the example. Okay, as the SBT, they are going to do extraction from the natural products. Okay, they want to know whatever compound that they are having in their mixture. Okay, this is one of the way to actually identify it. Okay, so the path flow for the HPLC will be visualized as the solvent reservoir, your high pressure pump, your sample injector, separation column, detector, and whatever that comes out after that, it will be waste collection. That's why in the HPLC machine, you will see there's a few bottles, okay, on the outlet of the tubing. This is what all your waste collection, okay, beside from your solvent reservoir. Okay, if you have seen the instrument before, okay. So moving on, how HPLC work. This is simplified. This is a simplified version of step-by-step guiding. Okay, for those who, I don't think this will be your first time to run HPLC. If those who already done the work, I think you're already being properly guided by like assistant, hopefully. Okay. So starting off, you must know, identify your mobile phase, how your phase flow. This usually in the form there, you need to state out, okay, what will be your flow. It's quite small, right? Okay, your flow rate here, okay, and then what will be your pressure. Okay, these are two criteria that you need to fill out beside temperature, ramping temperature, so on and so forth. Okay, so step 2 will be your sample injection, okay, whereby you will be injecting your sample. Okay, your volume is starting from 1 until 100 microliter only. You cannot be more than that. Most of the time, the more you injected, it doesn't mean that how to say, it doesn't mean that the more concentration that you are going to have. Okay, because the column itself is quite narrow, so they only permit very few until max 100 microliter. This is what I've been using. Okay, it will be allowed to flow into the column before it coming out from for you into the detector. Okay, this is also being controlled by your mobile phase, whereby it will also before it being elucidated out, okay, through your carrier, okay, beside your stationary phase. And the component separation, this is where your the core of your chromatography, whereby your stationary phase, your mobile phase will be playing their roles, okay, on doing so. Okay, so as a sample band, okay, most of the time they will being introduced into your column. So from there you got adsorptions, okay, you got residence, dissolve, and then you will migrate, and further on, so on and so forth. This process will be repeated as a cycle for each and every one of your compound mixture. Okay, your compound inside your compound mixture. Okay. So last but not the least, then you start to detect. Okay, whatever coming out from the end of your columns, okay, the compound most basically will be detected by generating signal. You need to generate signal because whatever compound coming out, either you use the detector UVVs for this case. Okay, from here you are going to get whatever signal from the detector. So this will be a real-time acquisition. Okay, most of the time you're going to get the inputs of frequency. Okay, in frequency terms, typically will be starting minimum. I think the baseline will normally, if you see the graph, the baseline will be starting from 10 until max. I think not max, roughly okay, about 80 hertz. Okay, by creating a time resolved profile. So from the profile that later on you're going to process, okay, the data processing whereby you comparing whatever signal that you have there as a baseline for correction. You do some noise filtering. This is all being done by the software. Okay, and some peak integration so that you are going to compare with your CDS database so that you might given a set, I think a few okay, whatever possible compound, okay, that's going to be how to say it's going to be identified. Okay, so this is much more towards quantification. Okay, for those who are doing, let's say they are doing some calibration curve, all those things, they can do it as a quantification process. You also can do it as qualitative, okay, process using this particular instrument. Okay, so it can be done on both sides. Okay, but if quantification, I think you need to prepare a series of concentration of the to say concentration of the solution of the possible compound that you want to trace. Let's say I want to trace ethanol. Okay, so I prepare, sorry, ethanol, but I want to detect, let's say, phenol. So phenol, I prepare it in a different concentration. So I having a calibration curve. So from there, okay, then I will plotting the graph, and then I'll see the concentration from the data processing on the frequency that I get. Okay, you will change normally into the signal, okay, as a peak. Okay, most of the time. Okay, and how you're going to calculate the concentration? You are going to calculate the area below the graph. Okay. Okay, so you must okay. This is what I already covered. Understand the chromatogram, whereby you got the baseline, you got the peak, detention time, peak area. Okay, which means from here peak area and the height you can calculate on your concentration. Okay, this is much more towards quantifications. So the key for performance metric, okay, this one more towards troubleshoot. Okay, so the efficiency and the resolution most basically depend on first with your column efficiency, whereby you measure the number of theoretical plates and then you calculate the peak width and from the retention time as well. So the higher the M value, the column efficiency, it will indicate a better separation capability. So your target will be this, okay? You will have a higher value of N. So typical value we are looking at is 5,000 until 20,000 plates for conventional HPLC column. And you also can reach over 50,000 if you are using the ultra high pressure performance of liquid chromatography system, okay, HPLC. But unfortunately, we don't have in UMK. We only have our basic HPLC. Okay, so for resolution part, the quantity of the degree of the separation of two adjacent peak, okay, the proper separation, the better, okay? So the resolution most basically will be 1.5 or greater, indicates that the baseline is separated well. If not, then your baseline will be having a lot of noise. And then essential for accurate when you want to do it in quantification. There are a set of formula that you can calculate. I'm not quite sure why the slide, the wording is quite small. Okay. Never mind, you can enlarge it later on. Okay, so for selectivity and sensitivity, so selectivity is you measure how well your chromatogram system actually distinguish between your two analyte, okay, or the two different compound, okay, by the retention factor, your K, okay, for your two peaks. So by improving the selectivity, most basically you need to check on your mobile phase pH. Okay, either you run it in acidic or basic, it will actually change the K value for your retention factor. And then you change organic modifier type as well and adjust the temperature, or you may select different type of stationary phase chemically, which means you changing. Okay, in other words, is you change the column. Okay, for sensitivity is the detector, the ability to generate the measurable system, the signal at low analyte concentrate. Okay, so the higher the sensitivity, which means that you only got bits of analyte, it can detect straight away. Okay, so the lower the concentration, it can detect, so that which means this system or this setup is very sensitive. Okay, this is partially useful okay, when you are doing quantification process. Okay, whereby for extraction purpose, okay, you only extract a bit, but you just want to identify whether the compound there is it present during your extraction. Kalau you dapat the sensitivity is very low, you can still detect, which means the instrument setup sensitivity is very high, which is good for your research on quantifications. But they got limit of detections. So the lowest concentration producing signal, which will normally will be 3 times of your baseline noise. This is what being calculated previously when you're doing the setup. And then there are also some limitation on the quantification, whereby the concentration give 10 times of the signal with acceptable precision. This is particularly will be playing a major role for your background noise. If your background noise can be flattened out using the software, most basically you're going to do some setting on the software. When you got a very good in terms of the noise leveling, so that you're getting a very strong signal even though it's very low in terms of your concentration for your analyte. Okay, so other factors that actually affecting your separation will be I only highlight, but I'm not going deep into that. I just want to highlight there will be mobile phase, some column parameter, temperature, your flow rate, your injection volume. Okay, so these five usually these five factors okay is playing the role on affecting how good is your separation between the two peaks. Okay, so next, some troubleshooting common issue that you're going to have most of the time okay, you got pigtailing or fronting, okay, whereby you got one peak going up. You can see my highlighter, right? Okay, you got one peak up, there's your peak going down. When going down is not a very smooth separation, is just entailing, okay, at the back there. So this actually is being caused by some of the symptoms where we can identify as asymmetry on the peak with extended trailing and leading to edges. So most of the time, what caused this particular problem, if you are getting this type of chromatogram, what causing the problem is most basically the column is contaminated. the void is formation inside the column, and then sample stationary phase and secondary interaction that may be occur when you are doing your setting, okay, which means that your setting is not so good, and then there are possibility that your column is being overloaded by the sample. So inject more sample doesn't mean that you get a very good separation. So try to limit within the range, okay, that I have stated previously. So what do you need to do if you have this type of causes? So the solution will be you need to flush. You need to flush your column with a strong solvent, okay, and then reduce injection volume or adjust the mobile phase pH and replace the column if it is damaged. Okay, most of it is cracked, will also give you such a chromatogram, okay, on the pigtailing. Okay, the second thing that you might occur problem, okay, some troubleshoot problem that you might occur during your analysis will be pressure fluctuation. Okay, this is what you're going to get. You're going to get an erratic and steadily increased system pressure and noisy baseline. Okay, what cause? Okay, what is the cause will to this problem will be air bubble in the pump and partially blocked, free or tubing, okay, or some warm pump seal, or the column is having blockage. These are the possible cause. How to solve it? You need to degas your solvent truthfully lah. Okay, when you are doing your analysis, maybe the solvent that you have choose is quite volatile. Most of the time it's some of the VOC compound. Okay, and you need to prime the pump, check the pump. There's any leakage or not. This is what you need to check. And then you also need to check the seal, whether the seal is worn, tore. Okay, and then you need to clean or replace any frit or gut column. Okay, if there's a dirt or some of the residue of your sample is being found on the column, you need to clean it up, okay, on the guarding, okay. Okay, the last but not the least, your poor resolutions, okay. If you're having a poor resolutions, which means there will be overlapping of the peak, inability to separate the target compound. So let's say inside there, your complex mixture, you got 5 compounds. So the 5 peak is not separate very clearly. Okay. A good chromatogram, if you got five compound, you're going to separate. Then you're going to see 5 peak, one after another. Okay, in a certain wave. Okay, so if the peak is overlap, so which means you got a very poor resolution on your chromatogram. So the inability to separate the target compound. So most of the problem occur is inadequate in terms of their selectivity or insufficient your compound efficiency and inappropriate your mobile phase that you're using is not good in separating your compound, your analyte, and excessive extra column bond that actually broadening, okay, which means that the column or stationary phase that you choose is not proper for your compound, okay. So these are basically the cause for you are getting a very poor resolutions. So how you're going to solve the problem is you actually optimize your mobile phase composition, increasing the volume most of the time, adjust the pH or temperature, or use longer or more efficient column. Okay, by minimize the deep volume, the connection. Okay, these are the solution that you might how to say solve the problems. Okay, these are the common issue. So some practical tips for undergraduate when they want to run the HPLC. Most of the time when you run HPLC, you're being assisted by the lab assistant. So I think UMK you don't face so much problem lah. Okay. So most of the time the lab assistant will inform you to do some sample prep. Okay, always filter lah your sample through a 0.45 micrometer or finer membrane filter to remove any big particulate and ensure that your sample solvent is compatible with the mobile phase to prevent any, because we don't want precipitation or any peak distortion happen. Okay, so you must do your own literature search, okay, before you run your sample, because you need to do some setting. Okay, in the instrument dia bukan main ambil cucuk masuk and then you run terus. No, it's not happening that way. You need to do some setting. So do regular maintenance. This is not done by you, but most basically you need to flush the column lah. Each and every of your session when you run your testing on your sample on the HPLC. Okay, this is being done regularly lah by the lab assistant. And then the system suitability, whereby you run quality QC check lah, okay, on sample analysis to verify the system performance. Okay, this one also being done either internally, you do the calibration, or you do external calibration. This is also being done by the assistant, not by you. And then proper documentation, whereby you maintain a detailed record of your method, instrument condition, maintenance activity, to prevent all those problems that are being stated there. But some safety reminder also lah, because HPLC mobile phase often contain flammable organic solvent or corrosive buffer. So always work in a ventilated area lah. Okay, and then wear your appropriate PPE, and then dispose your waste solvent lah according to the safety guideline lah. Okay, this also hopefully lah being done by properly by our lab assistant lah. Okay, right. So some imaging trend on the HPLC, this like what I've already stated, the ultra high performance liquid chromatography or any hyphen technique that you can use. Okay, designed for your HPLC. These are some of the imaging trend in your HPLC. Okay, but whatever we have in UMK is the basic one only. Okay, so before I end, okay, some summary on mastering the HPLC basic lah. Okay, so you must know what's the component. Okay, the system approach. How you're going to, this is the most important part for final year project student, how you're going to interpret your chromatogram, and then how you're actually getting the chromatogram, and then you do comparison with CDS, and then some troubleshoot skill you must know, like I've highlighted the three. I think it's not limited to that three, okay, but that three I highlighted because it will be the common troubleshoot that the student is being found when running the sample. And last but not the least, you must do a very well maintenance. That's why lab assistant is quite busy lah when you want to run the sample quite often, okay, from especially lah different type of sample from different supervisor, different FYP, different project. So that each and every time they need to flush everything out, make sure the column is clean enough for the next run for the next sample. This is why satu hari sekaligus we cannot run a lot of different type of sample, because we need to do maintenance in between of different sample. Okay, that's the reason why it took quite a lot of time, okay, and effort from the assistant. So I think that's all from me. Some further reading recommendation that you can read through lah. Okay, if you want to know more about HPLC. I think that's all from me. Thank you very much. You got any question and discussion that you would like to discuss in this session, or I always welcome lah. If those who are running the HPLC, you have any problem on the identify or analyzing the chromatogram, you can always come and look for me lah for further discussion. Okay, so with that note, thank you very much. I will pass back to Dr. B.
Okay, thank you so much, Dr. Wong. Okay, if you guys have any question, feel free to ask. Dr. Wong will be very happy to answer your question.
I try my best if I can answer.
So, is there anybody here want to ask question?
Because from the chat there, I not see anything on there. I think it's quite clear.
Okay, so it seems like no question. But anyway, if you have any difficulty when using HPLC, or if you are planning to use HPLC for your research, okay, feel free to go consult with Dr. Wong. He will be very happy to help you. Okay, if no question, then thank you so much, Dr. Wong. I think that's it for today. Okay, and thank you so much, everybody, for attending this talk. Okay, so see you guys again in our next workshop series. We'll make announcement when we're gonna have it. Okay, all right. So that's it for today. Okay, have a nice evening. Okay, bye.
Stay safe during the flood
Yeah,
flooding
stay
season.
safe, Banjir. All right.
Okay, right. Bye.